Hello and good morning to everyone. I'm Siddesh, and my topic for my project was using spatial interpolation to determine transit demand and ridership in New York. Um, so, giving a short introduction just to have a recap on what I was planning to do is that it's just in usual transportation studies, we planners and transportation engineers use station to station ridership data to estimate travel behavior patterns. So, what I wanted to try was to estimate end to end travel data, especially in specific tracts where transit data may not be available. And so, the whole point was to check if we can get an accurate estimate of travel behavior. So, the main aim of the project, hence, was to spatially interpolate the transportation demand between point data sets of subway stations and then estimate the demand for different areas of the city. So the goals and expected outcomes was to conduct an extensive spatial analysis of the public transportation. Then the idea was to get a location-specific point data of transit stops, and the number of trips undertaken from these particular areas. And hence the aim of the project was to spatially interpolate between the transit stations, and hence we would be able to estimate the transit ridership values for the rest of New York. And this could help us look at different transit deserts and help us provide ideas on how we should be servicing these areas if not by public transit. So, this was just an overall idea of which borough has the highest ridership. So, we can see that Manhattan has the highest ridership. That also could be because of it being a city center. But let's see how we can go ahead with the data. So, coming to the analysis, the first thing that was done was to run a spatial interpolation. So as we can see on the map, the gray points are the subway stations for which the data was available. And from this data, this data was collected from the MTA, Metropolitan Transit Authority of New York, and based on which the spatial interpolation for the rest of the city was undertaken. From this mapping also, we are able to understand that Manhattan again has the highest ridership, but that attributes to Manhattan being the city center of New York. So furthermore, there is moderate ridership in the western parts of Brooklyn and Queens, and also the southern parts of Bronx, which is a given as these are like adjoining areas to Manhattan, and hence people would choose to live in these areas, and it would be easier also to commute. That can also be attributed to the high transit service which is there in these areas. Like if you see the points, we can see that there are more points also in these areas with respect to other areas which are like blue in color. And that so all of this is also due to Manhattan being a high intensity trip generation zone, which is as opposed to other areas like Eastern Queens and Southeastern Brooklyn. So now to compare this interpolation, the next step which we did was to chloroplet map the different tract-wise strip generation. So this tract-wise strip generation was taken from the 2017 ACS estimates of the census. And from this analysis, it is again, we can see we have mapped the track-wise trip generation, and then the points can show which are the transit service tracts. And again, we can see that Manhattan has a high trip generation across all modes combined. So there is a considerable amount of tip generation also in the Queens area, but then that could also be accounted by car trips because we have I could only take the overall trip generation due to time constraints. Um, so when even if we compare this map visually to the previous uh, color map, the contour color map, we can see that there are various similarities as well as differences. And now the percentage of the change can be estimated by making a scatter diagram of both the uh, plots, the estimates, the previous estimates versus the actual data. So just for the sake of what and how it was undertaken, we can see that for each tract, the centroid was computed using the Shapley library, if I'm not wrong. And then again, obviously, interpolation, this map is just overlaying the interpolation with the new points. From this exact map, we extra exported the point data for these particular centroids. And the last part was to make a scatter plot to understand how the actual ridership is uh, versus the estimated ridership, how much is it differing. So from the scatter plot, we can understand that there is a considerable difference in the estimates as well as the actual ridership. We can see that the transit ridership estimate is actually a little higher than like it's overestimated as compared to the actual ridership. And so this may or may not be a, let's say, dependable method to compute transit ridership, but uh, this is also because it's just a mathematical method for computing something as ridership, which is also based on user behavior, service fluctuations, frequencies, and other non-numeric parameters. Yet it is observed that to an extent there is a pretty good correlation between the ridership estimates and the actual trip generation. So if we had to further like study on this topic, we can use depreciation variables and other parameters to compute a more accurate estimate about between the um, actual ridership and estimates. But then, why do we need to use this method? Why is this required? So, I mean, coming from India, I have also like studied transportation planning in India, and Uh, unlike the United States, there are many countries where data collection is still a manual process. And like we used to use a codon-based roadside household and household sample origin destination service, so which are a very sample method for understanding what would be the transit behavior, like ridership and user behavior for a particular area. And so it was still a manual process for data collection. So if we kind of use this method, since like having a large scale sensor based data collection system is still a long way to go, depending upon investments and other. So it is a time consuming process as well. It will need a lot of time. So as of now, for certain studies, we can use tract-wise transit dot trip data is something which is not available. So we can use this method to compute estimated user behavior and ridership, which can then also be useful in estimating extensions of metro lines or even adding new bus routes in many developing nations or cities that are in the process of transit improvement. So hopefully. So just to relate it back to whatever we have learned in Geography 407, is that initially I expected to use uh, GeoPandas, Pandas, Matplotlib, PikeRidge, and Network X, Folium, Plotly, and Leaflet libraries. But actually, I ended up using the first four as I had expected, but then I also ended up using NumPy, AdjustX, and Shapely for some other even mapping and centroid estimation processes. So hopefully you liked this project, and I would like to hear your feedback on this project. Thank you so much.